In this video, we're going to integrate again for product of inertia, but this area is an area that's defined by two different lines. So in other words, it doesn't touch an axis. And so it's just a little bit different example, probably slightly harder than some of the others. But again, the process is still the same. And we're going to use three different DAs. We're going to use a DA is equal to dx dy. We're going to use a horizontal element. We're going to use a vertical element and show you how to set up each one. So this is a straightforward example. We're going to use the product of inertia in differential form, di bar plus dA times x tilde y tilde. But again, di bar for a square or a rectangle is 0. And so we basically just end up with the integral ixy is the integral of x tilde y tilde times dA. If we use a double integral where our dA is dx dy or dy dx, then x tilde is x and y tilde is y. And so we can integrate y from x squared to x, and then x from 0 to 1. And if you evaluate that double integral, we get 1/24 meters to the fourth for this area, which is 0.0417. If we choose to use a horizontal element, then we'll use the parallel axis theorem in differential form. We have an x right and an x left, and it's dy thick. And so my x right is equal to the square root of y. My x left is equal to y. So my dA is square root of y minus y dy. My y tilde is y. My x tilde is the average of x right and x left. So it's y plus square root of y divided by 2. So when you set up the integral, the single integral, y tilde is y. This is x tilde. This is dA. And you can expand these guys out and do the integral. You also could just plug this directly into your calculator too and let it do the work for you. But either way, we get Ixy is 1/24 meters to the fourth, or 0.0417 meters to the fourth. That's a horizontal element. A vertical element, again, we're going to use the parallel axis theorem in differential form. Our vertical element is dxy. And so we're going to express our y top and y bottom in terms of x. Our y top is x. Our y bottom is x squared. So our dA is x minus x squared times dx. My x tilde to the centroid of the dA is x. My y tilde is the average of y top and y bottom. And so it's 1/2 of x squared plus x. I plug those into my integration, do the algebra, and I integrate, and I get Ixy is 1/24, which is 0.0417 as expected.